Hey guys, our final lesson for the school year. We're going to be talking about dividing radicals here. Very similar to multiplying, so if you guys thought that was pretty easy, this shouldn't be too bad. But again, this is the last thing that you really need for geometry honors. We talk about the quotient rule. I'm going to give you the quotient rule. We're not going to apply it too much here, but it can be applied. We're just going to do things a little bit different, which I think is easier. Quotient rule says basically if you're dividing a quotient, okay, in other words, if your radicand, the number underneath the radical, is a fraction, we can split that up, the square root of A over the square root of B. Okay, that's what the quotient rule says, and that allows us to go further and do what we need to do with radicals. Okay, and you guys will get further into detail later on, sophomore, junior year with that. But there are two things you got to remember when you're doing and when we're simplifying radicals. One is that we are going to simplify very similar to multiplying. Outside, anything outside with anything outside. And we are going to simplify anything inside with anything inside. Okay? And again, just like multiplication, everything must be put into simplified radical form. Okay, since we're talking about division, the only thing we're going to note here, no radicals in the denominator. Okay, and we're going to talk about how to get rid of them if they pop up down there. Okay? All right, so here we go. Let's rock and roll here. So number one, I have the square root of 75 over the square root over 2 times the square root of 18. I could try to simplify inside here and inside here. I guess we could do that. 3 goes into both of those. 3 goes into 75 25 times, so I can cross out the 75 and put a 25 here. And then 3 goes into 18 6 times. So that was inside with inside. So what we end up having up top is the square root of 25, on the bottom 2 root 6. Okay. So the square root of 25, we know that can be reduced. We can put the 5 up top. And the bottom is in simplified radical form. But if you notice in the cloud here, what we just said is you can't have radicals in the denominator. Okay, so we have this root 6 down here that we need to deal with. So this is called rationalizing. Okay, and this is really big for next year. Last big topic, we want to rationalize. Okay, and that's how you get rid of radicals that are in the denominator. And all you do is you multiply the bottom by that radical you want to get rid of, which is root 6, and you multiply the top by the radical you want to get rid of. And the reason why you multiply whatever you do to the bottom, you do to the top, because this is a form of 1. And if I multiply this by 1, it really doesn't change the value of this. Okay, so up top we have 5 times root 6, which is 5 root 6. And on the bottom I have 2 times 1, which is 2. Root 6 times root 6, which is root 36. So I have 2 root 36. Now the square root of 36 is 6. 6 times 2 is 12. So our final answer here is going to be 5 root 6 over 12. And that is reduced. That's our first one. These are pretty tough, I'm not going to lie. I am not doing some of the problems that we would normally do, but I feel like you guys really need to see this before next year. It's going to be helpful for you. All right, so we're going to go over here, and I have a 6 root 6 up top, and I have a root 90 on the bottom. Okay, so I think 6 goes into both of those. 6 goes into 6 once, and 6 goes into 90 15 times. So what we have is we have 15 root 1 over root 15. So the square root of 1 is 1. 15 times 1 is 15. And the only issue with this is now we have a radical again on the bottom, but we know we're going to rationalize, which means if I want to get rid of the root 15, I'm going to multiply the bottom by root 15 and the top by root 15. Okay, so what we end up with here is 15 times root 15 is 15 root 15. On the bottom, root 15 times root 15. We know the shortcut is going to be 15. And now when we look at this 15's on the outside, this 15's on the outside, and these guys can cancel, and our final answer is root 15. Okay, so moving on, taking a look at this one represents a little bit of an issue. The 2 and the 3 here can't be reduced. The 5 and the 12 can't be reduced. So we got to get rid of this radical. I do notice that 12 we can break down. We can think of 12 as 4 times 3. Okay, so I'm going to pull out a 2 because the square root of 4 is 2. And I'm going to rewrite this, keeping the top 2 root 5. This is going to become 6 root 3. Okay, maybe you realize it too as well. The 2 and the 6, the 2 can reduce to 1. This can reduce to 3. So right now I have a root 5 up top, 3 root 3 on the bottom. Nothing can be reduced on the outside, nothing can be reduced on the inside, and now I'm going to get rid of the radical. I want to get rid of root 3, so I'm going to multiply the bottom by root 3 and the top by root 3. So I got root 5 times root 3 is root 15. Let's do it this way. Root 3 times root 3 is root 9, and the square root of 9 is 3, times this 3 here will give us 9. Okay, and now this is reduced. Even though 3 can go into both of these, this is inside, this is outside, you're done. Nothing more you can do here. All right, so we're just trying to use this idea over here. Simplify anything outside, anything outside, anything inside, anything inside, and it has to be in simplified radical form, which means no radicals in the denominator. Okay? All right, a couple more here. I think it's going to be helpful for you guys to see most of these because these are a little tricky. Except we'll probably end with 5. Okay, so the rule is I can reduce anything outside, 3, 1, and 1, so that can't be reduced with anything outside. Anything inside, the 35 with the 7 or the 35 with the 45. All right, so I think I'm going to reduce these big guys here. I know 5 goes into both of those. 5 goes into 35 7 times. 5 goes into 45 9 times. So what we have is I have 3 root 7 up top. And I have root 7 times root 9 down below. And we know the square root of 9 is 3. So what I have up top is I have 3 root 7, and what I have on the bottom is 3 root 7. So these 3's, I know you guys see that, and these 7's cancel, leaving us with 1 over 1, which is 1. That was pretty cool. All right, so let's move on to the last example that I think you need here. And again, it's anything up top with anything on the bottom, since these are fractions. Now there's nothing on the outside. Well, there's 1's, but they can't reduce. So what I see here is the 3 and the 15. I'm sorry, the 5 and the 15. 5 goes into 5 once. 5 goes into 15 3 times. So this is what we have. Root 3 times root 3, root 1 times root 8. Okay, root 3 times root 3 is the square root of 9, which is just 3. Root 1 is the square root of 1 is 1. 1 times root 8 is root 8. And now I have a couple issues. This is not in simplified radical form, and we have a radical in the denominator. So the first thing I'm going to do is simplify this. I'm thinking of this square root of 8 as 4 times 2. So it becomes 3 over 2 root 2. And now this guy has a radical in the denominator, so I'm going to multiply the bottom by root 2 and the top by root 2. So I've got 3 root 2. Root 2, 2 times 1 is 2. Root 2 times root 2 is 2. 2 times 2 is 4. These can't reduce any further. Outside, outside. And we have no radical here. This guy is looking good. All right, so that's it, folks. That's dividing radical expressions. Your homework's not going to be too bad. It's only going to be 9 problems. You want to make sure you make your way through those. I will be giving some quizzes on Friday, 3 of them to close out the year. I think you guys have done an awesome job. You guys know that. And yeah, good luck with this, and see you on Friday.